Test. 1, 2, 3. Test. Can you hear me?
I think you're good.
Okay,
If
good.
Yeah.
Yeah. Welcome, everyone. Thank you for having me. We'll do whoever has the best. I just came up with this, by the way, when you were introducing it. I flew just to meet all of you. I flew in last night so I can come and spend time with you. So thanks for coming. Whoever has the best social tweet, I will send you an internal engineering only. It's called the Hawaiian Redpanda shirt. Okay, it's super cool. It's only designed internally for the engineering team, and so whoever has the best social tag Redpanda or tag me, it doesn't matter, and then I'll mail it to you wherever you live, right? So just you send me your T-shirt size, and then we'll mail it for you. So that's your incentive.
And hashtag the compute collective. Do not miss that. Do not miss that. All right, let's get started. Okay, Alex, thanks for doing this. I know it's a trip for you, but we appreciate it, and we promise that the Chicago data AI community is growing, and I think a lot of people are interested in what you're doing because I got messages, and I know streaming is a growing space that we're going to talk about, so it's pretty cool. For folks who don't know Redpanda, it's a fast-growing leader in the data streaming space. They've raised about $165 million from phenomenal venture firms like Lightspeed. Google just announced that company grew 300% this year. Customers grew 179%. Last year, they grew by 5x and have blue chip customers, just to anyone feeling comfort around that. Cisco, Activision, ShareChat, Jump Trading, Vodafone, Moody's, and many others. So phenomenal company, and I think it's one of the, I have a huge hope for the company to be a strong contender in that space. And Alex is a rock star in the streaming ecosystem. You'll hear his story. I think he's been I just call him superpower to be a streamer for a long time. So he's going to share more of that. So let's maybe kick off maybe learning about Redpanda and the cool mascot that you have. We'll get to that. I think it's pretty cool. But let's start with your story. I mean, how did you get to Redpanda? And I think not a lot of people know that you're unique, that you're not only a founder, but you wrote a pretty big piece of the early code as well.
Yeah,
so maybe kind of walk us through that a little bit.
Yeah. I guess by means of introduction, I had worked on distributed compute frameworks in the past. And so I wrote a thing that looks like Apache Flink in C++. I wrote it back then in a scheduler called Mesos, which is now dead in the Apache attic. But it was a competitor to Kubernetes. And at the time that I wrote Concord, it was like the best scaling scheduler. I think the claim to fame was Twitter. And so anyways, I built that, and then I sold that company to Akamai, and I couldn't find a storage engine that could keep up with the volumes of data. And frankly, to speak to the ethos of this meetup, like, as an engineer, you don't have to ask for permissions. So like, you just open up your laptop with like Emacs and GCC, and like you write the thing you wish existed because you can. And then so in 2019, I had worked on a bunch of low latency RPC communications. And I was like, hey, if I combine the HFT techniques with big data, I think like there's something here to try and tackle the Achilles heel of streaming, which was cost and complexity. We'll get to that. And so I left Akamai, and I had sold the company, so I like had some flexibility. I hired a couple of my friends, and then we just started building the thing I wish I had. And I didn't know, honestly, if it was going to succeed. I was like sitting in shorts in Miami in 2019, because it was like where I spending time. And then 3 months later, I was like working like 18 hours a day. I didn't have kids back then or anything. And so, I'm going to show a demo. And to those of us that have built a console application, you'll get it. But when I showed Redpanda to my wife and I hit enter, and like the terminal just hits the next line, and I was like, did you see that? And she's like, I'm still waiting for the demo. It's very anticlimactic. But my list was up, and I decided to move to San Francisco. And frankly, the company took off, right?
Yeah.
So we onboarded the largest electric car company in the world, largest company by market capitalization, some of the largest bank, largest CDN. By the way, this is just like a Docker file thing on like docker.redpanda.com. I hadn't even like made it source available on GitHub. And so that was the initial thing. And I felt really lucky in that, like, as a nerd, you sometimes maybe dream about changing the world in a very specific way, and then like it sort of happened, after 5 years of work. But that's how it started. It started like from a deeply technical background.
That's awesome. And if folks, maybe you didn't share, Alex is from Colombia originally, so
Yeah.
is an immigrant, but and was at NYU, and obviously since then been in the streaming space forever. Maybe before we dive into Redpanda, the product, the company, share with people a little bit about why is data streaming important?
Yeah.
What kind of applications? I think it's all around us, but maybe you can share about why everyone should care about data streaming, or rather pay attention to what's happening, and then what has been the evolution of the streaming.
Yeah, the evolution is a really interesting piece, but let me kind of level set the room. I think it's useful. And so I think if I talk in computational terms, right, streaming needed one particular theory improvement that Tyler at Google added, which was callback. You can think of it as the cron job. And so with a callback, you can now have a superset of both bounded batch and unbounded streaming data sets. And so by and large, I think batch is a historical artifact of how we got here, but it's not how the future is going to get built. Because if I give you a tool that is both cost effective and easy to use, but it's a superset of the things that you did before, like why wouldn't you use it, right? I'm sort of obviating the answer that you can and you should be doing things this way. And I think that largely we haven't adopted streaming-like technologies because of cost and complexity, right? Those were the two real Achilles heel of streaming. And so doing things in batch, putting things on S3 was really cost effective. And then you set up this discretization of the timeline, like at 6 a.m., at midnight, whatever, the top of the hour, you run a batch job and it consumes some files and it produces a different set of files. And the impact that we've seen for some of these large Fortune 2000 customers that you mentioned is, I think they remember this like identity provider took a 36-hour like file to batch program to file to 170 milliseconds. And it like fundamentally changed the amount of money that they were able to make. And so there's really multiple ways of looking at that. One is from the technical perspective is you can prove mathematically that with a callback, you could process both bounded and unbounded, right? You just have to set a timer callback that says, call me back at the top of the hour. And really the last two things was which the company originally started like trying to do with the product was make it super easy and really cost effective. So I think that's kind of what has held streaming back, and now it's finally hit escape velocity. And it's just, let me leave it at that. I think that's a
And I mean, what are the examples of applications that I think average consumer touches? I think where you see it's more prevalent, and then obviously enterprises are, I think from event and logs that are coming at you, and all the kind of data science work they want to do around it, seems like that's pretty needed from a much better improved architecture than we had the PubSub setups before.
Yeah, it's fascinating, that evolution. And so to give some classical examples, and then we'll give some more modern examples. And so on the classical examples, there, like we're in a finance space, so like trading, right? Like when the Apple ticker does a crosshair with the Google symbol, maybe you buy or you sell whatever symbol you're interested in. But Uber Eats is a good example, right? Like Netflix user preferences. I was talking to this bank, and effectively they were able to have a 300% improvement on customer conversion when they, at the time that you withdraw money from the ATM, if they present you with an offer right there, I was like, hey, would you like to use credit instead of your debit? They had a 300% improvement in customer conversion. What they were doing before is like, we notice you use the ATM. I'm going to send you an email at midnight, and they had basically close to zero conversion. They're like, well, maybe we can send it like an hour. And so they like really dialed up the Spark job, and they're like, I'm going to pay some money, but I'm going to try to get this person within the hour. Had like a couple percentage improvement conversion. And then they moved to streaming workload. And at the time that they transacted the credit card, they presented, would you like to do this from your credit? They had a 300% improvement in conversion. And like that is a very practical thing that happens across the board, whether it's like Twitter messages or like LinkedIn notifications or emails or fraud detection or credit card scoring. Right. It's like actually the world runs in real time. It's just like most businesses aren't, and somebody's going to eat your lunch.
That's right. That's awesome. That's fascinating. Yeah. Maybe getting into Redpanda a little bit. I think I obviously have heard you quite a bit talk about how Redpanda is kind of a drop-in replacement for Kafka, right? Everyone knows Kafka. That's obviously good on them to obviously put streaming on the map in some sense. It's an open source product, obviously, so we know that. You also talk about hardware as the platform for data streaming. What do you mean by that? I mean, give the audience a little bit of view of what modern data streaming means to you, and how Redpanda is kind of focused on multi-core hardware and so forth.
Yeah. So I mentioned Redpanda started from like a deeply technical roots. I think I was the youngest principal engineer at Akamai at the time that we made that. We got acquired, and so the ideas there is that to the practitioner, running Kafka felt like distributed system whack-a-mole. You're like, well, is it cruise control, or is it the HTTP proxy, or Zookeeper, or the schema registry, or the brokers? Like, my application isn't working, so like, which one of these systems like started crashing? And so that was like a really important pillar. The second pillar is that the laptop that we're going to run a Zoom with, or where the Zoom meeting is running from, right? That laptop has a disk that is 1,000 times faster than the old bottlenecking computing, which was the clock tick of the spinning disk. And so if you read, like, discard the marketing, git clone on your local laptop, another like Emacs, or I guess people using this AVS code, and look at the orchestration of the thread in a memory model of all the top projects. They're using a work-stealing algorithm because it was designed for an old bottlenecking computing, which was the clock tick of the spinning disk. And so given that hardware is now 1,000 times faster, not 1,000%, 1,000 times faster, then you can't eliminate essential complexity. You can only shift it around. And it shifted away from the clock tick of the spinning disk into CPU coordinations. How do I keep the cores busy? And so the second insight is, if I were to start from scratch, what would I do differently, right? And so the first thing that you would do differently is you would make it super easy. You would make it a single binary. So instead of deploying 5 systems, you would take one file, and you put it on like 1, 2, 3 computers, and you're done. Basically, the entire deployment model. The second thing, and somebody asked me in the audience when we were like chatting, grabbing coffee, or I was grabbing coffee, most people were grabbing a drink, was like, where's the latency improvement coming from? And I was like, look, I'm not gonna pull a trick out of my pocket and say like, there's like this one thing, right? Latency is the sum of all your bad decisions, or at least that's how I think about it. And so for the latency, the idea was like in a multi-socket motherboard layout where you have like 2 CPU sockets, even on a single socket, this principle remains. When Redpanda boots up, we discover the hardware topology of the particular disk. And so some of you that have worked in supercomputing would like get some of these principles. You would map the particular L core to the memory bank, and you can just discover this you can ask the hardware, like, what is the memory bank, the DIMM, the physical DIMM, that is mapped to this particular core? And so when Redpanda boots up, it like locks the memory to that particular CPU core. And so the thing that we got by focusing on this like super low latency technique, like no virtual memory, right? Like all the memory is allocated up front. This like a thread per core architecture, this thread locking, memory locking, etc. Disabling like kernel settings like block system coalescing out of the page cache, etc. What it gives you is it gives you predictable tail latency. And with that predictability comes like a huge performance improvement. And so some of our blog posts are run by people that run the largest Kafka workloads at like the largest company by market cap, or like largest electric car company. So they're like true pros that have done this for years. And so this 34x, this 20x, this 16x, et cetera, on these workloads comes from like all of the micro decisions that led to the accumulation of those decisions came to basically you get much better improved on the latency. The insight being that with modern hardware, you don't have to choose between latency and performance. And so anyways, it's kind of like a slight deep dive, and I love talking about performance, so let me like talk
peel
about
back
this.
a little bit, yeah.
Just peel back at a high level. Those micro decisions gave people some of the performance improvement, and it is important to talk about it in specifics, because I think people tend to talk about performance in this hand-wavy way. It's like, oh, we wrote it in C++. I was like, yes, obviously, but it is not just that it's a different language. It is like a fundamentally different way of software structure, where concurrency is about the software structure, and parallelism, the simultaneous execution, is left up to the runtime of how many parallel CPUs do you get. So I'll talk about the future in a second, but that was like a different way of thinking about software construction that leads to a categorical improvement in latency.
One of the things that as people wrap their head around streaming, it's hard for them to put in what bucket are they putting in for optimization. Is it on the storage or processing? If I think about, I think about Flink as complex stream processing and guarantees around the state, right? But then I think about Kafka on kind of like the data kind of message queue piece. So how does Redpanda think about storage processing? How do you kind of make the trade-offs? What does that mean to you?
Yeah, so Redpanda is squarely on the storage side today. So I'll give you a sneak preview. This demo I'm going to give today hasn't been shown to anyone, so hopefully the demo gods will work with us tonight, and maybe it'll work, and if not, then I'll just talk about it. It's just how.
Good caveat. Good caveat. All right.
Yes, exactly.
Our mic wasn't working just before, so it's good.
Yeah, exactly. Okay, I joined. I just came to earlier, and like I was just like, hey, this like training of this particular thing, it's can we change the input training set? So I've been training something on my laptop while we were chatting.
That is true.
And so anyway, so to answer the question, where does Redpanda live, and how do I think about that? And so today, in production, Redpanda is on the storage side. And so you can think of it as a drop-in for Kafka, as a drop-in replacement for Kafka. So if you have a Kafka cluster running, either cloud or self-hosted, you can drop in Redpanda, and it's sort of like, driving a Ferrari versus like a Toyota RAV4, which is what my wife drives, right? Like you're sort of stepping into the future, or maybe an electric car is a better analogy here, but it's definitely on the storage side. And you can use compute frameworks like Flink or Kafka Streams or whatever, ClickHouse or SoupDish or anything that speaks Kafka, work with Redpanda. And I guess the point of highlighting, I think Steve, you and I were talking, we haven't had a single customer, not one, in the Fortune 2000, all the logos you mentioned, that has changed a single line of code to work with Redpanda. So we don't have client libraries. Like we're strictly focused, we're a hyper-focused company on the storage side.
Interesting. So, I mean, there's obviously a big question of compatibility. People are using open source Kafka. Many people might be sort of Confluent users. How compatible, kind of talk about the compatibility to Kafka in some sense, and then, maybe in that, as you talk about compatibility, but then also highlight some of the, I came across cool features like privacy first architecture, shadow indexing, and so forth. So maybe you can talk about those highlighting features as well.
So what we discover in the product journey is like, okay, so you start with these three things. Super easy to use, really fast, and you don't lose data. Great, people sort of get jazzed about it. That wasn't necessarily enough for us to like build a highly scalable revenue generating business. And that wasn't enough given, frankly, where other more mature competitors were at the time, right? So we've been in business for 5 years. And so the first year, that was the original, and it was enough to get momentum from really large players, but it wasn't enough to kind of go and become what we hope to be, which is the de facto way of how people should do streaming tech. And so what we added later was this idea of, so the cost structure for most clusters with Kafka today actually comes from disk, and it doesn't make any sense. I was like, disk is about the cheapest thing that you can buy on Amazon S3. Like, literally the most effective thing that you could do today is you can put data on S3. And just almost you forget about it. It's like it's an insurance thing. It just basically stores things that nobody ever looks at. And so it's like, well, why can we leverage this super cost-effective way, this tiered storage, while still giving low latency? And so we invented this tiered storage approach where we have in memory and on local disk just the working set. And so the way you think about it, you raise the level of abstraction. And you now think in terms of latency and throughput, like how fast and how much do I need to send? And then that's the size of your cluster, as opposed to sizing it because you need 7 days of retention or 3 days of retention. And so that's where the tiered storage implementation. And then as we got into more regulated industries, like banking is a great example, right? It's like a procurement process of like 12 months. And so like you win the technical team, and the engineering team is all excited to use it, and then you have to wait 12 months for them to get into production. What we learned is this idea of bring your own cloud. And so it comes with aligning ourselves with basically this room, like the people, hands on keyboard, actually making products real. the idea for me is if we make the people that are coding, like actually making products come to life, if we align our company with the builders and makers, all of you in this room, then we'll be a financial success. And so we don't charge for Amazon compute. And so we give up basically 35% of margin that we could be charging people. But what it does, it allows to align my success, sorry, I'm touching the microphone, with our user success. So like the more they use, the more successful we are, the more successful they are with the product. And so where BYOC is, you divorce the control and data plane. And the data plane lives inside the user's network. The control plane is still cloud.redpanda.com. And so that was an invention that wasn't here before we brought it to life, and it's our best-selling product. And so you get a fully managed cloud, but the data lives inside their network. And it's perhaps, I guess, to the company builders, counterintuitive, because we did walk away from millions of dollars. Like, if I decided to stop selling that, we'd probably make a little bit more money. But I think it aligns ourselves with like what Redpanda's like financial short-term success is, not how like the engineers, the nerds in the room want to consume data-intensive applications.
Yeah, you talk about the cost, which is really the trifecta in this thing, and everyone probably thinks through is performance, cost, and then complexity. Right? I think you've said that a few times in your talks as well. So I think Redpanda is generally pretty open, and on the blog post, you guys are very good about putting benchmarks. Maybe it's a good time. Everyone is thinking through here. Share some statistics, share some benchmarks against anyone who runs Kafka workloads, both from cost perspective and throughput perspective.
Yeah, we took a public analytics company out of the Bay Area that from 384 brokers down to 24. And so in hardware spend, that was about $3.5 million of Amazon spend, down to a few $100,000 of hardware spend. And so like, it doesn't matter how you slice it. And I think that we had like it's kind of fun for me when we get attacked by competitors, because it's like, well, what do you think is going to happen? Your customers are going to now test us, because like you have a page for us in your website. It's kind of fun, especially when you're the underdog. And so in dollars, that was like probably a meaningful. And then for others, so I think StoneX is very public about it. Jump Trading is being very public about it. You guys have talked about it. I think Alex Davis, the CTO, wrote a blog post that ended up being on our website. So you could talk about like I can't talk about the use case, but I could talk about the data volume. There's like massive, effectively market-moving data volumes being transacted to just a few nodes of Redpanda that are very vertically tall.
One of the extremely few times we have a blog post.
Yeah, exactly. Thanks, Alex, if you are in the room. I'm not sure if Alex is here today. Oh, there you go. Alex is in the back. So he's the CTO, and you can ask him questions. Alex, I don't know if you have any comment on the performance benchmarks and the things that we have said. I'm just curious.
So our first impression, right, is skeptical of your and how the we've got a very
Yes.
and better than I remember the internal where it's not, is it throw away our data or just randomly,
Yeah.
Talk about underselling. Come on, Alex.
Yeah, it's like a super technical group, the Jump group, and so you kind of have to like be pretty sure that the things that you come out of your mouth are gonna be real, because they're gonna like find like the nth configuration. And Alex is smiling because he knows this. And then they're like, hey, if I turn this configuration, I get like 1% less or 1% more. So it's actually been a super fun partnership. So there you go, from Alex's mouth.
That's awesome. Do you need to run sort of, if you're deploying Redpanda, run separate clusters and from a convergence system and map our converged setup? How does one think about that setup?
Yeah. So classically, I guess with competitors, you have two major components of cluster configurations. You have a quorum system, now called like Zookeeper or like whatever. In like the new version of Upstream, it's called Keep 500. It's a quorum service, but it's a separate set of computers tier. And then you have like your data tiers. With Redpanda, like look, you can't eliminate complexity. It's just like if the job is to send data and save it to disk, then like the job is to send data and save it to disk. That's the job.
Right.
And And so similarly with consensus, like you can't dance around this. And so the way we thought about it is we hired Dennis, who was working in Cosmos DB out of Azure with Leslie Lamport, to come and work with our transactional system on like consensus and actually extending the Jepsen report. But in terms of clusters, it's just the same file, it's the same binary, and then it onboards the complexity away from the user into the product. And the thinking is, I have like very highly skilled 200 engineers, people in the company focus strictly on one problem. We're probably going to do a better job than most people. Like we have one problem to solve. And so we decided to onboard Raft, and then we worked with Kyle Kingsbury, the person that writes the Jepsen report, to prove to the world, audited by an external third party. Right. When we started working with like larger companies like banks, I was like, actually this thing works and it's safe and it doesn't lose data. And so typically from a convergence perspective, there's like two modes. There's the edge mode, and then there's like the centralized. And so for Redpanda, for most customers, they tend to have just like a couple of really large clusters at like gigabytes per second. Yeah.
All right, I'm gonna ask maybe a very timely questions. In the world of hype around AI. What is the future of streaming in the age of AI and all the AI setups?
Thanks for asking. That's such a like freshly evolving idea. So I'm not sure if some of you have learned about this company called Poolside.ai. It was the CTO of GitHub. Yep. He just started a company in AI, and so I won't tell you what they do. But the CTO, so Jason is the CEO now. Right. The CTO, ISO, came and we did a live chat. So they used Redpanda, and they were actually testing a competitor cloud at volumes that they couldn't support, right? So this was like above 5.5 gigabytes per second sustained. And we only found out that they were doing 5.5 gigabytes per second sustained because we got a page. It's like, this cluster is doing 400% of its provisioned IOPS. And I was like, well, I can't believe it didn't crash, first of all. But so there's two ways. There is the foundational model building. Yep. So, ChatGPT, think of it. And so Poolside.ai is actually indexing the entire web. And their only storage is Redpanda. So all of the like ML and AI scientists that they hire consume the entire web. So about 70 trillion tokens is basically the internet, in case that you care to ask. And they're just sort of consumed and reconsumed all the time through Redpanda. That's like one category of users, probably on the higher end of sophisticated. They understand streaming. On the other end, which is where I think most of us are, is this embedding of hyper-specific models, right? So you take some base models, right, whether it's Gemma or Llama or Mistral, et cetera, and you take the parameter permutation, whether it's the 2 billion, 7 billion, or 12 billion parameter models, and then you deploy them on runtimes. And this is all very confusing because base models can like multiplex on different names of the same base model name. So like a Llama can run on a Gemma like CPP runtime model. And so, okay, the idea for this room, not to lose you, is you're going to train your models, like these micro models, and there's like Llama 2 or Gemma CPP or like BERT or whatever, with like hyper-specific problems. So in the case of finance, it would be like, I am going to approve this loan, or I'm going to detect this event as fraud detection. But it's like, per topic, hyper-specific, and that's where I think the majority of the world is going to go. And this is where I think streaming is going to go. Like Redpanda at some point needs to give people the primitives to leverage this like super fast evolving landscape in a way that's frankly consumable. Because even for people that are experts, it's just so like time consuming. You're like, can we get the nomenclature like at least baseline? And so all of the names are confusing because they all like represent very different things. And so this is where I think streaming has a place in the age of AI. It's both in the foundational model building, like Poolside.ai, where, anyways, I can't talk about what they do, but it's building a foundational model not too dissimilar from a ChatGPT. Very few companies. So we also, on our website, we have Midjourney. I think it's public. Is Midjourney on the website? Anyways, we have like non-OpenAI, but the second largest. I'm just like checking in myself if this logo is on the website. Anyway, they are. Okay, so Midjourney is also on our website. So you have like some foundational models, and then you have more context-specific models like Llama 2 and This is where I think this room will make the most money with AI. It's like this hyper-specific models, whether Steve, whether like you're trying to do some like smart pool coalescing of assets or whatever it is that you're trying to do. I was like, that's where the value will lie with the majority of people.
Awesome. All right. Well, why don't we maybe jump into Q&A a little bit? All right. Open for questions. Whoever wants to go first or has one.
All right, so you showed us a little Rust in the end there. Any plans to rewrite Redpanda and Rust?
Yeah, exactly. I knew this was gonna come, so thank you for being brave. Let's see. I don't know how should we say this. Perhaps this is a personal failing. Who knows? But when I started Redpanda, I actually started with Rust, and I found 5 compiler bugs in the first week. Now we have found a tremendous amount of compiler bugs with C++ 20 because Redpanda compiles the compiler to compile the libraries to compile the program. We want to live on the bleeding edge of the compiler because we get a bunch of like type safety and memory safety, and like we get lambdas and coroutine and like anyways a bunch of like really important things that we in the way that we want to structure the software. And so at the time I had written a RPC framework that was using DPDK for kernel bypass for basically microsecond level RPC round trip. And just to give you context, I think Open Solar Flare or something like that was around 20 microseconds round trip in 2019 between 2 computers on the tail latency on like P99 latency. The first open source version that I wrote, which I patched the flat buffer C++ compiler that eventually uses Arrow, was 26 microseconds tail latency on like the first pass. So I was like 6 microseconds away from like the state of the art. And so the gist was like, if Rust had worked the first week, I probably would have written it, but I was pretty comfortable in debugging C++. I had written it for a really long time. And the thing about storage systems is like, you kind of need to tame how much excitement you put into this thing. These things are, we're gonna own the data storage for many, many decades for many companies. And so building on something that another database company had built on for 4 years, they had large production workloads. It was C++, it uses coroutines. The team was an expert in writing C++. Then we chose to rewrite but I did start with Rust. I just found compiler bugs that I wasn't more comfortable, but if you go to the GCC mailing list, you'll find a bunch of the bug reports are by the Redpanda team. That's sort of what happens when you push the envelope of languages. Yeah, but anyways, thanks for asking.
What else?
Favorite use case for
Ooh. I'm like no, I know. I'm trying to see if I could share without sharing.
The question is, what's your favorite streaming use case?
No, I know. I'm just like filtering names in my mind. Space exploration, and so like actually shipping Redpanda to outer space, exiting the orbit in like a flying thing has Redpanda embedded in it. That's like one of the. I actually called my mom there. I was like. And she didn't get it, which was like the more frustrating thing. She's like, well, what does your software actually do? And I was like,
this is what I do, Mom.
you can't win. But anyways, so I think getting a ship to outer space is pretty cool.
I don't know.
Oh, lovely.
Let me just repeat for the audience. What is the relationship with Confluent, the
Yes.
other Kafka company out there?
Yeah, I mean, I think it's any company that is making $800 million in revenue is like a phenomenal business. And frankly, I want to make $800 million worth of revenue. That sounds like a great number. No, but not being facetious, I think they trained the market. And the way I see it is we're sort of the Google to the Alta Vista. There was search before Google. It's just I think that you get to learn from them. They're like super well capitalized. They're smart. They're like it's a dynamic market. I expect them to. I think the way that where they're trending, which is like much more corporate, much more enterprise, sort of like one throat to choke style business. Makes sense for where they're heading. We're aligning ourselves with the doers and the makers, and so it's like two different philosophical product builds. My thinking is if I give the builders the tools for them to be successful, we'll get to capture some value, not all, and then we'll make a ton of money at the end. But totally different builds, and I hope they continue to be successful. Like, let's see. You should comment on it, but the larger their valuation and numbers are, the larger our valuation are. So like I wish them success. Like, we're aligned. I was like, go make a ton of money. You make me more money.
I think we've established it's a very large and very fast-growing market. So there's room for multiple folks.
Yeah.
And every new player is obviously going to be faster and better. So this is great.
Yeah, exactly.
Other.
If you could go back in time, give yourself advice when you're first starting Redpanda from a business startup perspective, what advice would you give yourself?
I think when you build a company, you are your self-biggest critic, because it's perhaps the opposite. It's like, gosh, the number of things I would do differently, let's see. I think you have like a lot of anxiety as an engineer to sign the first $1 million check from a customer, to be honest. And I think like learning to appreciate go-to-market is probably the thing that took me a few years to learn. It's actually really hard to sell software. No one, like you're not gonna walk into any place and no one is gonna sign a $1 million check. Zero number of people. Like that just doesn't happen, right? But an engineer is like, well, I built the best tech. Like, why are the salespeople not like closing more deals? And you're like, well, you try. Like you call some people on LinkedIn and try to get them to take a meeting with you to see how fun that is. And so I think like my personal development has been to lean into more on the go-to-market side and like help the company grow. And so if perhaps I would have done that a little earlier. And so I did that about 3 years. So the company is 5 years old. And really the first 3 years, it was just me and a bunch of nerds in a room, friends, to be honest, just hacking together. When we got our first Series C check from Lightspeed, Arif is like, hey, do you want to meet next month? Is our lead partner at Lightspeed, $50 billion plus fund. I was like, no, why would I talk to you? Like we already got the money. He's like, well, I want to help you. I was like, but I don't have a product. Let's talk in 8 months. And so I was like really focused on building. By the way, Arif is like the rainmaker of Lightspeed, which is like one of the best venture funds in the world. And so anyway, so leaning into that a little early as an engineer. But perhaps if I was a product or like a go-to-market, I would have a different answer. So for me, it was leaning into that earlier on.
Thank you.
Yeah. All right. Who was the first one? Was it? Okay. Yeah.
Go ahead. Speak loudly, sir.
Yeah, on the topic of go-to-market, you said that the first year you saw multiple so what was that about?
Yeah. First, remember that I built the software for me. And so, as in like, if Alex being a principal engineer at Akamai, like, would I use this software? And like, just really be honest with yourself. I think sometimes as builders, you ask your friends and they don't want to disappoint you. They don't want to tell you that your idea sucks because they don't want to hurt your feelings. I think people are really averse about having what is classically known as hard conversations in American culture. And so if you come from a different place, maybe like my family is more honest and they're like, no, that's a bad idea. And so I was kind of used to more honest feedback in that way. And so focusing on that early on really, but I was like, so I would call friends and they would do perhaps this is like the California thing, like, oh, this sounds really cool. Like, I was like, no, it's not the question. It's, would you pay me money for this thing? And like, that's like a very different question. And like, would you pay me $10? They're like, okay, maybe. I was like, okay, would you pay me $10,000? Okay, I need to run this up. And so once I got someone paying me $170,000, I was like, okay, that's a real enterprise company. But until we landed on that, the obsession was never on making money. actually the obsession was always on getting this in production. Like, how many users can I get in production with level 0? I would almost give it up for free, but I didn't because I wanted them to go through the mental loop of paying for this physically. But it was never about the 170K or the 100K or the 50K. It was like, your business depends on this software, and you trust me to run it. And so, like, Jump was actually one of our earlier, on the earlier customer front, and they like really battle tested Redpanda. That was really fun, and that was the focus. I was like, this is the kind of person that I want to partner with. And I remember Alex and I were having a chat. They're like, hey, we tend to break most software. And so I was like, yes, this is exactly it. It wasn't the money exchange. It was mostly about getting people committed and running them in production. That was the focus. Does that answer your question?
All right, we maybe have time for one.
I think
Nikolai,
go
ahead.
What do you want to find building? Not fine.
Yeah.
Not here.
Mars.
You say what?
Build Mars.
Yes, exactly. I don't know if I could talk about it, but space exploration is really fun. I think like there's this shift, and so like ultimately, what is the goal for me is, I said this earlier, and I meant it in a non-facetious way. Just like, if I can convince developers to build a world with Redpanda, like that would be like super fulfilling. And I know through that journey we'll be able to build a great company. But if we could do one thing, if we become the de facto way of how people build the future, like for me, that's the dream. Like it's fun, and I get to partner with the smartest people in the room, and so that would be the goal.
So, this is great. I think what we're gonna do, I know Alex has a cool demo that he's promised, so maybe we do a quick demo. You wrap that up, and then we follow with Q&A.
Yeah. Okay. Awesome.
All right.
So I want to show a sneak preview of embedding a BERT model into Redpanda and co-deploying it in the same physical compute. And the thinking here is that there is a shift to vertical compute instances, right? This is like where the cloud is heading. NVIDIA is building a thing called the AI cloud. They talked about it in their public earnings. And so the idea is that before like the LLMs and this AI hype, computers were horizontal in one particular dimension. So they would have like some CPU and either lots of IOPS or lots of memory, and they were tall in like one dimension. But the shift is now when you rent these computers for AI, they have really tall memory. They have a bunch of GPUs. They still have CPU and actually really fast disks. And there doesn't exist a way to necessarily leverage these particular tiers of computers. And so it turns out IBM did this study where 90% of the dollars spent in AI is actually in inference, which is runtime, right? Like CPU clock cycles of running the thing, not CPU clock cycles or GPU clock cycles on training the thing. The running is much more expensive in terms of computational dollars than actually the training. But what people have learned is they're like, oh, they spent $200 million on training of this particular model, and we're actually the other $800 million is going to be spent on running the GPU clock cycles. And so inference is where most dollars are going to go. And most of us sort of get confused in this world of LLMs. Like we all want to try around to play around with it, but if you sort of go down into this rabbit hole, there are more people talking about it than actually people trying and playing around with the tech. It's mostly on like design and architecture and white documents and RFCs than actually people trying this tech. And so this is where I think streaming could, in particular Redpanda, given its thread per core architecture, an original message pass and interface could leverage GPU. And so the thinking here, and so what I'm showing here is a loading an Onyx model, which is this open network exchange format. And so you can take a particular training set and then serialize it to a file called a .onx. And then you can load that model and then do inference on that particular model. And so this was BERT, and then the weights and everything, we downloaded this from Hugging Face. And so the idea is that you would send a message to a particular topic. The topic will decode the Kafka payload, and then send a message to the GPU via local function host. They're called host functions. And so you would send the host function to the GPU. The GPU would do this instruction, is called matmul, basically multiplication on the GPU, or like basically actually thousands and hundreds of thousands of those. And then would send back, would post the results back to the CPU. And what effectively you've done, you've relieved the pressure from the clock ticks of the CPU, and you've offloaded those clock ticks onto the GPU. And the net is that you get to leverage this vertically tall hardware. And so the model that I took is, huge disclaimer, I went on Wikipedia before this demo, and I just went on like the jump trading Wikipedia article, and so I'm not sure if any of it is real. Take that for what it's worth. And so I trained this BERT model, which is a 24 million parameter model. And you can ask it questions via the Kafka API, and it will give you answers in a different topic. And the model I was training actually didn't work. And so I'm just going to show in my terminal the history right now, because this is how live demos happen. And so the way you would define it is you would take this. It's kind of a thing just for the demo. There's more work to be done. I haven't shown this demo to anybody else. And so the thinking is you take this content, and it's called content here as a variable. And you go on the Wikipedia page and you copy paste that. And in real life training, you would send the training data to a particular topic because you might need to update it. And then you get to ask it questions later. And so the input topic would be questions. Free-form questions, and so we've trained BERT model in a Q&A style question, so free-form question and answer, and then the thing gives you a particular model output in answers in text. And so what happens is the inference, the way this works, is that you tokenize the sentence, and then this idea of batching is you send the question in like some tokens to the LLM. And then it'll give you, basically it's a for loop, you can think of it, and then it'll give you back some text that you respond then back to the other topic. So, but you don't have to care about how any of this works, because this is all behind the scenes what Redpanda would give you. The only thing, and then this is actually part of the free version of Redpanda, so this will not be an enterprise tier, because the goal is to empower people to use it. And okay. So I'm going to show you, so this is the Rust. It loads up this token model, and frankly, it just loads the Transform SDK, and then basically has a question and answer particular model on it, and then I'll talk about it. The way we train it is we go in Python. And so in Python, I'm going to increase the font here a little bit. We download Torch and a bunch of the transformers, and you basically produce an output directory called mobile BERT. So this is the BERT model that is running on your Android phones for those that are using Android. This is the model that Google uses. And it writes the file in a non-export format. And then in the Redpanda Transform SDK, I'll talk about this here in just a second. We detect that it's a Rust binary. This is the input and output topic, and then the environment. And Redpanda RPK, when you do RPK wasm deploy, it'll compile your Rust function, which is this main.rs. It'll compile down to wasm, and then it has this thing called include bys, which it literally will like concatenate the model file, the Onyx model file, into the Rust binary, and ship that to Redpanda as a WebAssembly module. And then it executes on the broker. And so you eliminate the latency that tends to be associated with the ping pong of data between the host computer, say your Kafka brokers, and your third-party processing system, let's say Flink or TimePlus or whatever, any of the database. And instead of ping pong, and you're like, well, just tell the GPU to do the thing. Like, why do you have to go across? For some things, you will, right? This isn't a general thing designed to replace all of the stateful workloads. This is very purpose-specific to basically lower the barrier, and in my opinion, give the best developer experience of trying to use these AI models, where we focus on the runtime and weights and all of the embedding, and you simply get to train it with your particular data set. And so this is how I think most enterprise companies will do. And so I have to launch on the shell here for a second. This is a particular step, but on the The questions that I asked the model was, again, disclaimer, this was on the wiki. I don't know if any of this is true. In fact, I know some of these numbers are true from some are not true from some conversations, but it's what's available on wiki. I asked how many employees does Jump Trading employ, and then you produce that particular question. And so list the offices, Jump Trading, who founded Jump Trading, and when was Jump Crypto started. And so if we go to the terminal, these are the list of offices that were on the Wikipedia article. It says that the number of employees listed on Wikipedia is 700 employees from Jump Trading. It says that the founders were Paul Girinas and Bill DeSoma. And then I think this 1999 is probably incorrect on Wikipedia. But apparently it says is when Jump Crypto was started. And so if you give it garbage, you're going to get garbage. But the point was to showcase where like actually making it super easy for people to deploy and consume and effectively take advantage of vertically tall hardware. Anyways, I haven't shown this to anybody, and I'm sad that you couldn't see me hit enter, and then you see the terminal. But it's very anticlimactic, as you can imagine. I was like, RPK topic consume. I was just testing it out this morning. And then this is the retraining of the particular model. So you can see I was actually trying to build this. But the retraining didn't work on any model. Anyways, I think with that, I'll just jump into Q&A, and I'll stop sharing.